Dear viewers, today I shall discuss a single footing. Column size 20 inch by 20 inch and dead load given 275 kips and live load given 200 kips. FMC concrete strength 4 KSI and FY steel strength 60 KSI. At first, we have to calculate average soil and concrete unit weight. We know soil unit weight 100 and concrete unit weight 150 divided by 2. Average soil and concrete unit weight is 125 psi equal to 0.125 psi. And effective soil pressure 6 minus 0.125 into 6. The base is given 6 feet below from the ground, so we subtract 6 from 0.125 into 6. So effective soil pressure is 5.25 kSF and self weight of footing, total dead load and live load into 10%. So we get 47.5 kips and area of footing equal to total unfactored load, dead load plus live load plus self weight of footing divided by effective soil pressure. We get 99.52 equal to 8 into 12.44. For workability, we can take for 8 into 12.5 square feet. Now we have to calculate net upward pressure on the footing. Net upward pressure on the footing equal to total factor load divided by area of footing. Total factor load 1.2 dead load plus 1.6 live load divided by area of footing. Then we get 7.07 KSF. Now we have to check thickness of footing. Assume thickness of footing equal to 27 inch and D equal 24 inch. 24 inch is without covering. Now we have to check the punching shear. The punching shear, critical shear. We know punching shear create D by 2 distance from the outer of the column. D by 2 distance, D by 2 distance, D by 2 distance, D by 2 distance. Then we have to calculate column size is 20 inch. D by 2 equal to D equal to 24. So adding 24 and 20 we get 44 inch. Convert into feet 3.66. Then perimeter of the footing who is working punching shear. So the length and width are same. Length is 44 inch into 4. The perimeter of the footing is 176. Critical punching shear equal to total area of the footing minus area of the punching. Area of the punching is 3.66 square into net upward pressure 7.07. Then we get 601 to 5.29 kips. Now we have to calculate allowable shear for concrete. Allowable shear, punching shear for concrete equal to 4 pi root over F times CBD. Or for phi magnitude is 4.75 and root over F times C concrete extent 4,000 PSF and V naught perimeter of the punching area of the footing 176 and D width of the footing without cover, then we get divided by 1000, then we get 801.44, who is greater than critical shear. So pouncing shear is okay. Now we have to calculate the beam shear. Check the beam shear. Beam shear, we know that beam shear is working d distance from outer of the column. Her length of the footing is 12.5 divided by 2, and column size is 20 inch into 20 inch. So half of the column in 10 inch divided by 12, convert into feet, minus d distance. D distance is here. D is 24, convert into feet, then we get 3.42. 3.42 length is here footing 3.42. Now critical shear along long axis. Effect, we are checking 1 feet steep. So critical shear is net upward pressure into 1 feet into 3.42. Then we get 24.17 kip. Shear along short axis, critical shear, net upward pressure 7.07 into 1 feet steep into the distance from outer of the column, then we get 1.66. So multiply by 1.66, we get 8.243 kip. Allowable concrete shear equal to 2 phi root over f times CBD. Here phi 0.75, root over f times C concrete stand 4000 PSF, and B 1 feet steep we have considered, and the width of the footing, then we get 27.32, who is greater than critical shear. So footing thickness is okay. Now we have calculate moment along long axis. Moment equal to QU, net upward pressure into ln square, which ln square outer side of the column of the footing, and L1 other side of the footing. So along long direction moment, net upward pressure 7.07 into 5.42 square, and other side 8 feet, we get 830 kip per feet. Steel. So area of the steel is, we know area of the steel is divided by phi Fy d minus a by 2. Here moment 830 into, convert into inch, divided by 5.9 into 60 into d. The magnitude of d is 224. We have calculated as FYD 0.85 f times CB, who is a 1.45 divided by 2. We get 7.42 inches square steel. Now we have to calculate moment of the along short axis. M equal to net upward pressure into outer side of the column of the footing 3.16 whole square into length 12.5 divided by 2, we get 442.91. So we have to calculate steel as equal to m divided by phi Fy d minus a by 2. Then we have calculate as like as before. We get steel 4.12 inches square. We know minimum steel for the footing BDFY BD divided by 200 BD divided by Fy. 200 B is here, B is equal to length into 12, convert into inch, 150. So 150 into D is width of the footing. Then we get 12 inches square. So we can use 8 nong bar 16 nus or 8 nong bar 9 inches center to center, both direction. Plane of the footing, length 12.5 feet and width 8 feet, and here A and B. Along axis 8 nong bar 9 inch center to center, and B use 8 nong bar 12 inches center to center. Here putting detailing 8 nong bar 9 inch center to center, both direction. Here is reinforcement detailing.